Okay, here's the second topic, solving trigonometric equations. This time we're going to be solving them by hand. So I have some steps that you can try and follow to help you out. So use algebra techniques like collecting like terms or factoring to try and isolate the function. So for example, if you're trying to solve 2 sine theta equals 1, divide by 2 so that you've isolated sine theta. It's by itself, sine theta equals 1/2. Step 2, find solutions over an interval equal to the period of the function. So we know that sine has a period of 2 pi. Same for cosine, secant, cosecant. If you were solving a tangent function, you would be looking over an interval of pi. So if we're thinking, of an interval 2 pi for a sine function, and we want to know where that height is 1/2 on the sine function, you could get that off the unit circle, or you could get it using a graph. If you're on the unit circle and you're looking for a y height of 1/2, that occurs at pi over 6, and then the y height again is 1/2 at 5 pi over 6. So those would be the solutions you could list on an interval 0 to 2 pi. Or if you want, you could think of the graph. When we unraveled the unit circle and we got a graph, the y height is 1/2 here and here. This would be like y equals 1/2, and that's at pi over 6 and 5 pi over 6. So whether you want to use the graphs or the unit circle. So we know in our example, sine theta is 1/2 at pi over 6 and at 5 pi over 6. The third step is to say, well, let's say we're at the pi over 6. That's not the only number that would give you a y height of 1/2. You've traveled this far. You could get a coterminal angle, travel another 2 pi, so pi over 6 plus 2 pi. Or go backwards, subtract 2 pi. So any coterminal angle also gives the solution. So the way you write that is you add and subtract 2k pi if it's on an interval of 2 pi, or you add and subtract k pi if it's on an interval of pi. So in our solution, we'd say it's pi over 6 or any coterminal angle plus 2 pi k. And it's 5 pi over 6 or any coterminal angle. Go ahead.
Could you say negative 11 pi 6?
Okay, so another thing is when we solve these, we don't usually use the negative angle as the number that goes right here. The number that comes first should be a value between 0 and 2 pi. But saying a negative angle would be another solution.
What about for cosine, since it becomes positive, a negative cosine? Would that work?
What do you mean?
Everything's sine.
The trickiest part is remembering that for tan and cotan, you add and subtract k pi, not 2k pi. If you look at the graph, it's kind of easier for me to explain how you could spin around the unit circle. So we picked out the pi over 6 and the 5 pi over 6 as the values that give a y height of 1/2. And then the thing is, it doesn't just occur here and here. When you look at the graph, it occurs every 2 pi. You pick it up. So if you add 2 pi or if you subtract 2 pi, you start picking them up. So you get repeats on those 2 initial ones you found. But the 2 initial ones should be between 0 and 2 pi when you list them. So here's some for us to try and solve on our own. 2 cosine theta minus the square root of 3 equals 0. Give a general formula for all the solutions and then try listing 8 of these solution values. So the first thing we're going to do is try and solve for that inner function, the cosine theta. So add the root 3. And then divide by 2. So now you're taking kind of the cosine inverse of both sides. You can solve it written like this, or if you want, you could think about it like this. Either way, what I'm trying to say is what angle makes the cosine equal to the root 3 over 2? And it needs to be an angle between 0 and 2 pi. So the thing to remember if you write it like this is that those 0 to pi boundaries don't hold anymore. You're just anywhere between 0 and 2 pi. Okay, perfect. Pi over 6. And then 2, 3, 4, 5. Pi over 6. Wait, we're on cosine. Yeah, we're on cosine. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that both of these, cosine is the root 3 over 2. So we say that theta equals pi over 6, and theta equals 11 pi over 6, or any multiple of those. So plus 2 pi k.
So we don't have to write the solution for it. We can just write that then. Plus 2k.
Well, so this part that I've just written would be the general formula for all the solutions right here. Now that we have the general formula, what we're going to do is plug in k equals 0, plug in k equals 1, and to get 8 solutions out of it. When I plug in the k's, if I leave my answer the way it's written now, I'm going to have to get a common denominator 8 times and add the fractions 8 times when I plug in the k's. So what may be a smarter thing to do is change the way the answer's written. So give a denominator 6, which would make this a 12. And factor out a pi. Can you guys see how I did that?
Divided by 6.
And divided by 6. So I took the pi and pulled it out. And from the first one, it leaves over a 1 and then a 2k. 1 plus 2k.
You put the pi over the 6.
Is this supposed to be 12?
All right, let's try the second one also. So if I make denominator 6 again, this becomes a 12. Pull out the pi, pull that out front, and you're left with 11 plus 12k. So if it were me, this is how I list my general solutions. Then it makes it easier to plug in the k's. So if I plug in k equals 0, and right now what I'm doing when I plug in the k's, I'm listing 8 of the solutions. So if we plug in 0 for k, and I'm going to write it out for you one time. The first one becomes 1 plus 12 times 0 over 6. So just 1 over 6, right? So the first one's pi over 6. And if you plug in 0 in the second one, 11 pi over 6. Then plug in k equals 1. So 1 plus 12 times 1, 13. And then the second one, 23. Plug in k equals 2. Let's see, we've got 24 plus 1. And 24 plus 11. So we've got 6 solutions. We need one more set. I'll just move it up here. K equals 3. So let's see, 36 plus 1.
37,
And 30.
not 35.
Yeah, right, yeah. And then the second one, 36 plus 11. Usually, once you get them all listed out, the way you summarize them is in braces. And usually you write them smallest to largest. So you do braces and then all your different values in here.
Is it the case that with everyone, it's going to just be adding a sum because each one is adding by 12?
That it's going to be adding like a constant difference?
Yeah.
Mhm. For this one. Do you know what the constant difference is you're adding?
12.
Which is 12 divided by 6, so it's really 2 pi. Right, and this is how I would list the answer for give 8 values of the solution. We plugged in different values of k. So there was a student question that asked, could you list negative numbers or do you have to only list positives? And the answer is you can also list negatives. So you could have plugged in k equals -1, k equals -2, and started getting some negative angles in here also. Here's the second one for us to try. Solve the equation cosine of theta minus pi over 4 equals 1. By the way, whatever's in these parentheses is called an argument. So the argument here is theta minus pi over 4. When we list the solution here, we need to give exact values, and the values need to be between 0 and 2 pi. So step 1, isolate cosine of the argument, and it's already isolated. Step 2, what angle could you plug in here to make cosine equal to 1, and it needs to be between 0 and 2 pi. Cosine equals 1 at what angle? 0. So now we know the thing that needs to be plugged in is 0. So we want to set 0 equal to the theta minus pi over 4. What we're saying is that if you take pi over 4 and plug it in right here, then pi over 4 minus pi over 4 equals 0, and cosine of 0 is 1. Does that make sense to everyone? Okay. So that's the theta that works, plus or minus 2 pi k. Now you need to plug in k values and double check if there's any other that could potentially work. And are you guys seeing any that could if you plug in k's? Yeah, there's no matter what k you plug in, there's no others that are going to work and still be restricted between 0 and 2 pi. This is the only one that works. So theta equal pi over 4 is the answer. When it gives a set interval and it just says solve, you give a number. If it doesn't give an interval here, if that's missing, then you give the general formula plus the 2 pi k.
But yeah, because